Hello. Okay. So in this lecture, I'm going to give a brief idea of the microprocessor. Okay. So I'll discuss the introduction part of the microprocessor. So first of all, what is the meaning of microprocessor? Microprocessor is a programmable, multi-purpose, clock-driven, register-based electronic device that reads binary instruction from a storage device called memory, accept binary data as input and process data according to those instructions and provide the result as output. Now, this is the definition of microprocessor. Now, what does it mean? Microprocessor is programmable. So, programmable means try to understand each of the term. Programmable means the programmer can write the program and it can store inside the microprocessor and it can execute that program. Okay, so that's why it is written as programmable. Then the next term is multi-purpose. So multi-purpose means this microprocessor will be used for doing many operations. It's not like I don't know you have the idea of microcontroller or not. Microcontroller generally used for a specific operation, whereas your microprocessor will be used for multiple operations. Suppose, for example, whatever computer you have or personal computer you have that you are using for simulation purpose, gaming purpose, documentation purpose, for so many purposes you are using. So microprocessor will be used for multi-purpose, not for a specific purpose. Then it is clock driven. Clock driven means some external clock you need to give to the processor so that processor can work with the clock pulse. Okay. Then register based. Register based means it will have some register. The microprocessor will have some register which will be used for the temporary storage of data or for some particular operation also these registers will be used. That then after that what it is written that reads binary instruction from a storage device. So some instruction means suppose if programmer writing some code. So that code will be stored in the memory and uh, processor will read those instruction from the memory and accordingly it will do the operation. Okay, so that's why it is written. It reads the binary instruction from a storage device called memory. And let me tell you, whenever you are writing the instruction, generally, in case of microprocessor means whatever 8085 or 8086 microprocessors are there, generally people use assembly language code. Okay, we use assembly language program that is known as ASP, assembly language, sorry, ALP, assembly language program. Okay, so the thing is, this assembly language program, for example, we use this type of instruction in assembly language program. For example, this is a simple instruction I'm giving for assembly language program. Move AX comma BX, and that is for 8086. This instruction is available. It means this instruction is applicable for 8086. So this instruction, whatever I have written, this is in assembly language program. Okay, or assembly language code I have written. But the computer won't understand this assembly language program. So some assembler will be there, some assembler, ASSEMBLER, some assembler will be there, which will convert this assembly language program to machine language program. Machine language program means what? Machine language programs are nothing but means machine language code, not programs actually, machine language code. So machine language code is what? The combination of zeros and ones. So this binary data, okay? So whenever the programmer writing in assembly language program, this program will not directly understood by the processor. So assembler will be there, which will convert this assembly language program to machine language code. And machine language code is nothing but the combination of 0 and 0101. Okay. So whenever you are writing this instruction, so in the processor, this instruction will be stored in a memory location in the corresponding form of 1010 or some combination of 1 and zeros. Okay. So that's why it is written that reads binary instruction. Binary instruction means whatever instruction you will write that will be stored in the binary form of 1010 from a storage device which is known as memory. and accept the binary data. So processor will do operation on the binary data and it accepts the binary data in input. Suppose some input device is connected to the processor, it will accept the data from the input device in binary form and the processor will process the data and accordingly whatever instruction it has got, accordingly it will provide the output. Okay, so this is known as microprocessor. Okay, so try to understand each of the term. So first, what I told, this is programmable means user can do its program and you can execute it in the processor, and the processor can be used for multi-purpose. Because I told if you have a processor means, for example, whatever personal computer you have that you are using for multiple purposes, not for a specific purpose. Then some clock is there. According to the clock, the processor will work. In the processor, some registers are there which will be used for the temporary storage of data, or maybe some other operations also it will be used. And then the next term is the next point is written that reads. It's a register-based electronic device that reads binary instruction, means whatever instructions are there that will be stored in the binary form in the processor, means processor memory actually, whatever memory is given in that memory only it will be stored. So it is written, it reads the binary instruction from a storage device that is called memory. So from the memory unit, processor will read that instruction in binary form and accept the binary data as input. So as an input, it will accept the binary data and it will process the data. And according to that, it will provide the corresponding output. So this is the definition of a processor, microprocessor. Okay. And a microprocessor in short term, it is denoted by mu p. This is mu p. Okay, this is nothing but a central processing unit. This is nothing but a central processing unit. Okay, so the processor processes the input output peripherals data that give result back to the peripherals to a function. Okay. Now, suppose if you have some input output device that will be connected through some peripheral component to the processor, and accordingly, whatever data you are giving to the processor, accordingly, it will give some result to the peripheral. So, okay. The first microprocessor was developed in 1968, but the commercial microprocessor came in the year 1971. And the number of the processor was 4004. Okay. So this is the basic means definition of microprocessor and its related information. Then if you want to understand the microprocessor in depth, you need to understand the internal organization of a simple computing device. Okay. So simple computing device generally contains these sections: a CPU or central processing unit, then it will contain a memory unit. Okay, some input output device will be there and some buses will be there. Okay, now CPU is nothing but central processing unit. Memory is the uh, means thing where storage will be done, means this is a storage unit where you can store some data or code. Then input output device, all of you know very well what is input output device, and all these things will be connected through three buses. These three buses are commonly known as system bus. Okay, what are the buses? Control bus, data address bus, and data bus. All these three buses are commonly known as system bus. Now, what is data bus? Data bus will do the data operation. Okay, so whatever data operation is there, that will be done through data bus. Okay, so data bus and buses is nothing but the connection of some wires. Bus is nothing but some wires through which means according to requirement something will be traveled. Suppose if it is data bus, data will be traveled. If it is address bus, corresponding address will be obtained through this address bus, and if it is control bus, some control operation will be done. Okay, now data bus, as I already mentioned, it will be used for the data transmission or to receive the data. Now address bus, it will indicate the address from where you need to means take the instruction, or where you need to read the data, or you need to write the data. Okay, so this address will be given through this address bus. Okay, suppose you have some memory location. Suppose you have some memory. For example, you have some memory. It will have two things. One is whatever the data inside the memory and how many addresses are there in that memory. Okay. So every memory unit contains two things. One is each of the address, and inside the address what data is available. Okay. So the address information will be given through address bus, and inside that address whatever data is there, that data will be collected through data bus, or the data will be moved through this data bus. Okay. Suppose sometimes we need to store, sometimes we need to read or write. If we want to read, then that reading operation means whatever data you want to read, that data will be read through this data bus. But the thing is whether we want to do read operation or write operation, based on that the control bus will work. This means if it is a reading operation, if you are doing a reading operation or writing operation, this will be controlled by the control bus. Understood? Because sometimes we have to read, sometimes we have to write. We means processor actually, what I am trying to mean. Okay. So data bus will do the transfer of data. Address bus will indicate the memory address, and control bus will tell you whether it's a reading operation or writing operation you are doing. That will be indicated by the control bus. Okay. And combination of all these three buses is known as system bus. Okay. Now, what is the purpose of each of the unit? It is explained here. Central processing unit, it does fetches, decode, and execution of an instruction. Okay. Now one point comes. If you want to execute some instruction, it follows three steps. First of all, fetch. Then you have to do decode. Means processor has to do. Then it has to execute it. Okay, so each instruction execution is done by three steps: fetch, decode, execute. Okay, now what are these things? In a very briefly, in a very brief way, I will tell, but I will make some video where I can tell the entire thing. Fetch means processor is collecting the instruction from the memory unit. Okay, this is known as fetch. Your instruction will be stored in the memory unit. Processor is collecting that instruction from the memory unit. That is known as fetch. After that, whatever instruction it has collected, it will be decoded. Because whenever the instruction will be stored in the memory, that will not be like whatever programmers write. Suppose move ax comma bx, that will not be in this form. Some corresponding binary code will be there, 1010, some combination will be there. So that thing will be decoded. That 1010 combination will be decoded. Means processor will try to understand what is the meaning of this code, what operation is telling about. Okay. So after fetch, the next step has to be decoded. Why? Because whatever instruction it has fetched, that is given in 1010 some binary form. So some decoding unit will be there, which will be used to decode the instruction. Yes, this move operation is, for example, if some move operation needs to be done, then for the combination of 1010, it will try to understand, yes, this is the move operation it is asked to perform. Okay, so after decoding that particular operation, means when processor understand, yes, this operation need to be done, it execute that instruction. So three steps are followed to execute any instruction. Okay. So these are the main functions of CPU. Then CPU must be equipped with necessary resources. Which are the resources? First one is register. What is register? Register is used for the temporary storage of data. Then the next thing is ALU. That is also very important. Okay, CPU generally need to be means CPU when a central processing unit is there, so this component has to be there. Okay, this component which I'm talking about, this component has to be there. Which are the component? These are the important resources. These are register. I told for what is the main purpose of register? To temporarily store the data. Then ALU. What is the full form of ALU? Arithmetic logic unit. Okay, what is the purpose of ALU? To do some arithmetic or logical operation. What is arithmetic operation? For example, suppose if we do addition, subtraction, multiplication, division, all these things are known as arithmetic operation. Then what is logical operation? Suppose if you do AND operation, OR operation, XOR operation, these are known as logical operation. So all these operations will be done by this unit, which is known as ALU, arithmetic and logical unit. Okay. Then the next is program counter. This is a very important thing for CPU. This program counter is some sort of register, and this indicates what instruction next to be executed. Its address will be given in the program counter. So program counter contains the address of the instruction which will be fetched next or executed next. Okay. So this will be given by the program counter. Then instruction decoder. I already told the purpose of instruction decoder. When processor fetch some instruction, it is given in 1010, some binary combination of 1 and 0s. So after that, processor has to understand what instruction it is talking about. So in order to that, some decoder unit will be there in the processor, which will be trying to decode that particular instruction. Okay. So for that, some instruction decoder is there to interpret the instruction fetched into the CPU. That is the purpose of instruction decoder. Then input output device, all of you know which are the input output device for a normal computer. For example, keyboard is the input device and monitor is the output device. Okay. Then some buses will be there. So what is buses? I already told it's a strip of wires, and these are known as buses. And three type of buses are there: address bus, data bus, and control bus. Okay. So address bus will carry the address bus will give you the address of the location where you need to access. Then data bus will carry the data information. Control bus will give the whether it's a read or write operation. Okay. Then if you understand this central processing unit components, and if you understand the internal organization of a computing device, then things are more clear to you. Means for the microprocessor, things are more clear to you. So microprocessor generally contains these sections. Okay, this is the block diagram of a microprocessor. So what are the things are there? So your processor contains ALU, arithmetic logic unit, as I already told, arithmetic and logical unit. Then it has some registers which will be used for the temporary storage of data. And what is the purpose of ALU? To do arithmetic and logical operation. And some control unit will be there, which will be controlling the entire operation. Some buses will be there where the input output device or some memory unit will be connected. Okay. So this bus is combinedly known as system bus. And I already told under this one, three buses are coming: data bus, then address bus, then control bus. So these are the three buses commonly known as system bus. And through these buses, input output device are connected, and RAM, ROM, some memory unit will be connected. And all of you know RAM is random access memory, and ROM means read-only memory. Okay, so memory unit will be there. So these will be connected through system bus. Okay. So this is the block diagram of a microprocessor, and let me tell you, this input output device and this memory units, RAM, ROM, all these things are externally connected to the processor, externally connected to the processor. Okay, but the idea is completely different in case of microcontroller. The microcontroller also have the similar type of components, but all these things are given in a single chip. All these things means your control unit ALU register means your CPU will be given in a combination with input output device with a memory unit. All these things will come in a single unit. Whereas in case of microprocessor, your processor and the input output device and the memory unit, all these things are externally connected through buses. Okay. So this is the end of this lecture. In the next lecture, we'll try to give some introduction of 8085 and 8086 microprocessor. Thank you.